Hi, this is browser security with HTTP headers, and if you want to follow along on your laptop, that's the URL to these slides, slides.com/davidism security HTTP headers. And you can find me at davidism on Twitter and on GitHub. So like the introduction said, I am the core maintainer of the palettes projects, which includes Flask, Click, and not Django. I don't know why I said Jinja. And I'll be mentioning Flask a little bit in this talk, but it's not really Flask centric. This is going to apply to whatever web application you're writing in whatever language, whatever framework. You don't even have to be writing a web application. This can apply to static sites. So, browser security. What do I mean by browser security? When you use the web and interact with sites, your browser stores information about that, like you're logged in, or this is the version of the data I retrieved. And you, the human, are also storing information like, oh, that was twitter.com, and I know that it looks like this, and I click tweet to post something. So the browser's storing information about you, you're remembering things about sites and how you've interacted with them. Browser security means the security measures Firefox, Chrome, Edge, or other browsers can take to prevent one site from pretending to be another site or tricking you into doing things you didn't mean to, such as revealing a password or performing an action with credentials for another site. So due to backwards compatibility concerns though, since the web is very old, many of the things a browser could do to protect you aren't enabled by default. So that's not to say they don't do anything. The browsers do try to help you be secure as much as possible, but they can do more if the application tells them to. It's basically like saying, I'm a modern web application with security in mind, so I don't use that old insecure behavior, don't allow it at all. But these aren't the only security measures you're going to want to take when you're designing a web application. There's, of course, things like escape user input or store hashes, not passwords. But I think when it comes to security, the headers that you can use to control a user's browser are really underdocumented, and they're just as important as everything else. And it's pretty fast to implement them all. So why not use them? So this talk is going to show you kind of what the different headers are and what the good defaults and first steps for using them are. But like every application, you have a different set of requirements for any application you're designing. So it's kind of going to depend on what you want your application to be able to do. That's going to inform how you configure all these in the end. And the executive summary, if you're using Flask, install the Talisman cores and CSRF extensions and apply them to your application. And you're already most of the way there. They're going to give you good defaults or at least get a lot of documentation about how to configure each of these options. Most of the things we're going to be looking at come from Talisman. The other two extensions are there mostly because they existed before Talisman did, or the features that they're implementing, such as cores and CSRF protection, were important before the headers that Talisman is managing. So you want to use all three. If you're using Django, there's similar extensions like Django security and cores headers. I'm sure there's something for Pyramid or your application of choice out there. And like I said, it's just headers. You can set headers in pretty much any web framework you're going to use. So yeah, that's it. That's how you do it. Done. Thank you. But yeah, so it's not very interesting if I stop there. So we'll take a look at what those extensions are doing behind the scenes. So what are HTTP headers? When you visit a website, besides the data that you send to the application, such as your username, or the blog post you're writing, and besides the data you get back from the application, such as here are all the latest tweets, browsers and other HTTP tools also send and receive headers, which are basically metadata about the request and the response. Key value pairs that say, for example, here I am the user agent curl. I am making the request, and I'm returning you HTML content. and it's this many bytes long, 13 bytes. This was a little hello world application that I accessed with curl. So within Flask, you can read the incoming request headers from the request.headers dictionary. And unlike curl, which I showed above, when a browser sends a request, it adds an origin header, which says what domain the request came from. So JavaScript code can't set this manually, so browsers are basically ensuring that your application has some information about where the request really came from. And it's going to use that origin concept in the browser itself as well to decide what to do when we set these headers. For example, you can use, for most of these headers, you can say, I'm going to deny it from everywhere, or I'm going to allow it from the same origin. So if it's my application, they can do these things, but other sites can't. Or you can have a list of allowed origins. So you can say example.com is allowed to use my API, but not foo.com. And sorry about that. And the application can set headers in response. And so that's what Talisman and Cores and CSurf are doing, is they're going to be setting headers and cookies every time your application sends a response back to the browser. Your browser's going to look at those headers and decide what to do next. So before we even get to headers, though, the fastest way to upgrade the security of your application is to serve it over HTTPS rather than HTTP. That means configuring your server with a TLS certificate, which encrypts communication between the browser and the server, so that other people can't see what's being sent. Let's Encrypt is a free open service that will get your server set up with a TLS certificate. Use it. You're already ahead of the game. But even with HTTPS enabled, there's still a security issue. Your server is probably configured to redirect HTTP URLs to HTTPS. So if a user goes to HTTP by mistake, your server is going to be nice and say, oh, you actually wanted to access in a secure way. But because there's that redirect transition, an attacker can get in the middle and handle that redirect itself. Now the user is still talking to the insecure site, and the attacker is seeing everything you send it. So the strict transport security header tells the browser to only access the site over HTTPS, even if the user types in HTTP. It won't even wait for the redirect. It'll just automatically rewrite the URLs. And in this case, it's going to remember to do that for a year in seconds, and it's going to also remember to do that for subdomains. So if you have example.com and api.example.com, they're both going to always use HTTPS when they're accessed. But there's still an issue. If this is the first time the user's accessed your site, then the browser doesn't know about this HSTS header that you've sent because you haven't sent it yet. So the same attack can still happen. An attacker can still get in the middle of that first request when it's upgraded. So the answer to that is preloading. So if you add this preload option to the end of the header, and then you register your domain on this HSTS preload list, the next time all the browsers release new versions, they'll include a copy of this list, and it will know automatically that if you go to example.com, it's HTTPS, even though you've never been there before. The downside of this is if you make a mistake and decide, oh, I don't want to use HTTPS, you're going to have to deregister from that list and then wait another month or two before browsers release a new version to get off of it. But you probably always want to be on HTTPS, so you don't really need to be worried about that. If you have a good reason for not being on HTTPS, come find me later and I'll tell you you're wrong. Now, while you're looking up and setting up HSTS, you might come across another acronym, HPKP, public key pinning. Stop. So this is another header you can use to tell browsers, not only should you always connect with HTTPS, but you should only trust this certificate. So if theoretically the attacker somehow got hold of your HTTPS communications and had their own certificate, this would make that fail because it wouldn't match your certificate. So while that sounds more secure, but it's even worse than the preload issue that I showed before. If you mess this up and you give if you give the browser the wrong key, or you lose your key and so you have to set up a new one, but you haven't told the browser about it, suddenly the user can no longer access your site until that expires, because the browser is always going to say, well, the certificates don't match. So it's really easy to mess up. It requires a lot more infrastructure setup, and you probably don't need this unless you're a bank or something. So wait on implementing it until you're really sure it's necessary and you're really sure you know what you're doing. So I'm not going to show what the header is or anything. Go look that up on your own when you're ready. So let's get into a couple easier headers. Now that you've got HTTPS set up and secure, the X-frame options header prevents the browser from displaying your website as an embedded iframe on another site. So for example, I at foo.com can't embed twitter.com inside my site and look like Twitter. And that can be useful on its own, since you probably don't want your site to be displayed in other people's sites. But it also prevents an attack called clickjacking, which Twitter and a lot of other sites did get hit with it a couple years ago, where if you can display another site in your site, you can also make that essentially invisible and put your own content over it. So you can make people think they're clicking like, oh, you just won $1,000, but in reality they're clicking, hey, check out this great product, tweet, and posting spam on their account. Or lots of other nefarious things. So you can set this header and it will tell the browser, don't allow embedding my site. Like if you get back a page that has this header, it's not allowed to be in an iframe. The most secure option is just the deny option, which says don't allow anybody. You can also do stuff like same site, so your own site can embed your site. I don't know why you'd do that, but you can. Let's see. The X content type options header. This tells the browser to allow data that makes sense for images, styles, and scripts. In older browsers, Internet Explorer, if an attacker was able to upload, let's say, like a JavaScript file that looked like an image, and you can do that if you're clever enough, Internet Explorer, when it rendered that image, would actually treat it as a script and execute the script. And there are various ways to attack that. So if you set this header, it will tell the browser, and it will also tell like Firefox and Chrome, but they were kind of smarter to begin with, but they will still be even smarter if you tell them to not do that. It'll tell them, hey, if it's a script tag, only allow JavaScript files, and only execute them as JavaScript files. If it's an image tag, only allow image type files and only interpret them as images. Don't ever try to be smarter than the application was. Oh yeah, one other thing. X-frame options is sort of deprecated. It's still useful for older browsers, just like X content type options is useful for older browsers, like old Internet Explorers. But it's mostly handled by another header called CSP that we'll see in a little bit. And another deprecated header, although it's still useful in some cases, is X-XSS-Protection, which is cross-site scripting protection. You probably want to turn it on and set it to block, which will prevent the page from loading if it contains content that looks like it was a script that was in the URL. So if I submit like a search query with some escaped JavaScript and the application for some reason decided to render it in the page, the browser will see that and say, oh, you got some stuff injected in, so I'm not going to render it. I'm not going to execute that script or anything. It kind of relies on heuristics though, and it's really only implemented by Internet Explorer and somewhat in Chrome. And they've both deprecated their implementations in favor of CSP. It wasn't particularly foolproof. There were a lot of ways to still get around it. And it's better addressed by the application, which should always be escaping user input when it's going to be displayed. but it doesn't hurt to set it anyway. So if you're sending cookies, so for example, if you have a session cookie in Django or Flask, you always want to make sure to use a couple or 3 options, the secure, the HTTP only, and the same site option. And that will tell the browser, only send this cookie over HTTPS, don't allow JavaScript to even read it, and only allow some types of cross-site use. You can also do same site equals strict, and that will only allow use on your own site, but that can cause some weird issues that people still aren't prepared for. So lax is a little easier alternative that still gives you most of the security. You would presumably still be using something like CSRF to protect against attacks from other websites anyway. But if you're using Flask, it will do this automatically for you, and Talisman will set up the secure option when you're in production. So when you're in development, you can still be on HTTP. Django has similar options to enable these things, but just make sure you're always limiting who can read your cookies. This one's fun, the referrer policy. So when you click on a link in a browser, the browser not only sends the origin header that we talked about a while ago, but it also, which tells the application what domain is sending the request, but it will also send the referrer header, which contains the entire URL that you came from, which can be useful for gathering statistics about who's using and linking to your site, or maybe having a redirect after login to go back to the page you were on. For example, GitHub has a page that shows what pages are linking to your repository. And I've used that to find cool blog posts about Flask before. But it can also be a privacy concern. So it might reveal a private URL that's internal to your company. Or it might contain your username. And now another application knows your username on that site, which can be useful to attackers or advertisers. So there's a bunch of different options you can use to control how the referrer is sent with this referrer policy. The one you probably want is strict origin when cross-origin, which is the longest option. This one says, send the full URL when I'm making requests within my application, but only send the domain as the referrer when I'm making requests from other domains. And only set the header if it's an HTTPS request, so the entire communication is encrypted. If it's to an HTTP URL, don't even send anything. Like I said, there's a bunch of other options to this. There might be one that's more useful to you, such as, oh yeah, it's okay to send the referrer to any site. I'm just a blog, you know. I want to let people know what article they're coming from. But that's really up to you, the application you're writing. So now we get to the really complicated headers. Those were the easy ones. Content security policy. And because it's complicated, it's going to be hard for me to give you a correct way to use this. What content security policy does is limits how, it tells the browser what resources it can load and from where. So for example, the strictest policy you can use is the default source is self, which says only accept resources from the application. Anything external that you try to load will just be blocked. You can decide, oh, I'm only going to load scripts from this location, from a CDN. I'm only going to load images from Imager, maybe. I'm only going to load fonts from a font website I use. This basically lets you allow only the things you actually expect your application to be using and deny everything else, which makes it a lot harder for attackers to inject other content into your page. It's fairly hard to get right, though. If you use this policy here, this default source self, that's very strict. You're probably going to immediately see issues when you try to load your page where things might not look right because you were relying on Bootstrap hosted in a CDN or jQuery hosted on their website. So the answer to that is to start with the most strict policy, look at the errors that come up, allow that refresh, see what the next error you get is until you've allowed only the resources you're actually using. And at that point, you can also look and see, does it actually make sense for me to be using these resources? Maybe I should be moving some of this content into a self-hosted location. Or maybe I also want to just allow images from Imager because people will be posting their own content and I want them to host it there. So you can get more complicated and you can say, well, by default, allow nothing and only allow scripts, AJAX connections, images, and CSS styles from my own website. So I'm not even going to think about loading fonts, for example. I'm just going to use the default fonts, so don't ever try to load fonts. So this is even stricter than the default policy. Again, you're going to have to tweak it, though. Or you can, for example, say, I'm going to use all Google's resources. I'm going to use their CDN. I'm going to use their font API. I'm going to embed YouTube videos. So Flask Talisman provides this nice configuration if you decide you're a Google application to allow Google APIs. Then we get to a more experimental feature. This one isn't 100% implemented anywhere, and I've had a lot of trouble figuring out how to use it effectively so far. But there's a new header called feature policy. This, unlike CSP, which says you're allowed to use resources from these places, feature policy is saying you're only allowed, like within my page, you're only allowed to use these features of the browser. So that can be like geolocation, auto-playing videos, using the microphone. Now there's legitimate uses for all these sorts of APIs, but you probably don't want to let advertisements, for example, start the microphone, right? So you can decide on a feature-by-feature basis whether to allow nobody to use it, whether to allow yourself to use it, or whether to allow trusted sources to use it. But unlike CSP, there doesn't appear to be a way to set a default policy, like setting everything to none and then allowing the things you want. You have to go through and disallow every single one of these features, which it is still in development though, so that might change as more people start to use it and experiment with it. But an example feature policy might be allow myself to play videos automatically, but don't allow anybody to use the camera, microphone, or geolocation. You can get as strict as you want with this, but you're going to have to be verbose about it. The last thing we'll look at, and the thing that's probably given you the most headaches if you've been writing an API, is cross-origin resource sharing, or CORS. And this is a newer browser feature to help prevent cross-site scripting, where it will say, if it looks like you're making a request from a different domain, a different origin, I'm going to check with the application first if that's allowed. So the simplest, or the most strict answer is, if my application is example.com, then I will only allow example.com to make requests to myself. So the browser will prevent any other website from making a request to your website. In many cases, that's exactly what you want. You might be like, even if you're writing a single page application where you have an API and a front end completely separated, you might want only your front end to be able to access your API. Now, this isn't going to prevent access to your API programmatically. Like, you could still install Python requests and make a request to that endpoint. Again, these headers only affect the browser. Requests doesn't care that I've sent back, oh, only allow example.com. It just ignores it. But that isn't really the goal of CORS anyway. It's to prevent websites in the browser where users have their information stored from making requests to other sites. So if you are writing an API that you want to be public and you want to be used by other sites, This is the thing you've probably seen recommended all over the place, which is just allow star. And this just allows anything to make any request. It's useful for public APIs, and it can be the right answer. Or you can decide, oh, I'm only going to allow these 3 domains again. So how does CORS work? There's a little more that you need to do than just setting a header. This is where extension like Flask CORS comes in handy. The browser will actually make a pre-flight request by sending an options request. And it will ask, hey, I'm going to make a post request with the content type header. And then the application needs to respond, yes, you're allowed to make a post request with the content type header. And then the browser will actually make the request. So coordinating all that and deciding what endpoints can handle what methods and what headers is a lot easier handled when you're using the extension. Okay, so to review, if you're using Flask, use Talisman, CORS, and CSRF. When you use these extensions, they're going to provide global defaults for your application and allow customizing the behavior per endpoint. If you're using Django, there's Django security, Django CORS headers. The CSRF protection is built in because Django has forms built in. You can even implement this just in your web server itself, Nginx, Apache, whatever you're using. The downside is this is going to just apply to the entire application rather than being customizable per endpoint. And you're going to need access to the server configuration. But the upside is it can be faster and simpler to set up. And sometimes that's all you need. Sometimes you just want to apply a global policy to your application. So I'll leave you with a couple of resources. These first 2, SSL Labs, will check your website to make sure that the SSL configuration, the HTTPS configuration you've created is good. It will evaluate that on a bunch of different levels. Let's Encrypt gets a pretty good score out of it right out the gate. Securityheaders.com will do the same sort of evaluation, but for the headers your application returns. So all the ones we just discussed. And it will tell you, oh, you don't have this header set, or it looks like you're allowing more than you should. So you always want to run your applications through these first 2 resources before you go live. The other 2 resources are OWASP, or OWASP, which I can't remember what it stands for now, sorry. But this is like the place to get security information for applications. And they have both a site that documents all these security headers and how they work and what the best practices are, as well as a cheat sheet project, which just says, hey, you know you want to implement this, here's what you should do. And they have those for most of the headers, as well as a ton of other application security concerns. So you should definitely take a look at that. And that's it. It's browser security with HTTP headers. Thank you. And
we have time for some questions. Does anybody have any questions? Oh, over there.
I think it was a great talk, and I like that you gave resources for automated ways to see if your site is secure and your APIs follow good header practices. I have a question though. Sometimes we have APIs that exist behind a network that's not accessible by, I presume, these third-party tools. How would you recommend auditing those if these tools aren't going to be able to actually see those?
I don't have a good answer for that. You know, I would guess there's probably something out there. OWASP might list something. You know, the place to start, just like starting with like a secure default, is maybe just saying, these are the headers. Like, we know that these are the headers. Here's the documentation for them. Are we actually returning them? You can write a unit test for that. But beyond that, I don't have a good answer for you. Sorry.
Okay. All right. Thank you.
Anyone else have a question?
Are there any browsers you would not recommend using because they haven't implemented important headers that, you know, protect
IE6, does that count? No. I think if you're using Chrome, Firefox, Safari, or Edge, you're probably in a good place. They have varying levels of support, but they're all pretty up to date. You can always use the Can I Use website to see how a header is supported in the versions you're expecting to support. But that's another one where it comes down to who do you expect to be using your site? Do you expect people who have very outdated browsers to be using it? Well, then you're going to have to make some trade-offs.
And then part two,
Okay.
is there a browser out there for like hacker users that, maybe want an X-frame of another site?
This is a white hat talk, so no, I don't
ethical
particularly
reasons.
know. Sorry. I'm sure there are tools out there. Be resourceful.
Hi. So very great talk. Apart from headers, what else do you think the browser should take care of?
What should the browser take care of? I kind of glossed over it, but when I showed the example of, or when I showed the HTTPS setup at the beginning, there was a little green lock icon. So browsers are making steps to better indicate what behavior is good and what behavior is bad. They're making better steps to indicate like, oh, we've auto-filled forms, or oh, you're a secure site, or this feature is enabled or disabled. I don't particularly know what I would say like they need to do more of. I think like just making the user more aware of these issues and teaching the user to look for these things so that it's not all automatic. The user is actually educated.
Okay, thank you.
Nice talk, thank you. I haven't used Flask CSRF, but I have built Jinja Flask apps with CSRF tokens, manually inserted tokens in something like WTF form, whatever it was.
Yeah, WT Forms provides an implementation of CSRF as well.
Right, but if I make a site quickly, I want to ensure that all my form fields are actually protected. I didn't forget to add a CSRF token somewhere or whatever it is. How do I check for that?
If you're using, I don't actually know about CSRF. I just know that it's kind of the more general option at this point. But if you're using the Flask WTF implementation, besides the form that will provide CSRF, there's also an extension you can wrap your application in that will always check for the header for any post request, and it will fail otherwise. So you'll know immediately, oh, I didn't include the header on this page, and there was a request for it. So that's kind of just a more global way to apply CSRF than per form.
Thanks.
Thank you. I think we're out of time, so can we all give David another round of applause?